This is the types of radiation as alpha particles. We said, okay, listen to this audio, please.
Types of radiation. Alpha radiation. Alpha radiation is made up of positively charged particles called alpha particles. Each alpha particle contains 2 protons and 2 neutrons and has a 2+ charge. The figure shown below is a nuclear equation showing the radioactive decay of radium-226 to radon-222. An alpha particle is equivalent to a helium-4 nucleus and is represented by here alpha. Thus, showing mass is conserved in a nuclear equation.
Okay, understand guys till now? Any problem? It's okay. Let's go to next slide. As this beta particle. Okay, we explained alpha particle, and now we are going to explain beta particle. What about beta particle? Listen please to this audio again, please.
Types of radiation. Beta radiation. Beta radiation is radiation that has a negative charge and emits beta particles. Each beta particle is an electron with a 1 charge. During beta decay, a neutron is converted to a proton and an electron. The electron is emitted and the proton stays in the nucleus.
Okay, so how can we explain beta particles? Who can explain with me? Saleh, can you explain it with me, Saleh?
Yes, Mr.
Can you explain it with me? Okay. So this is carbon. عليكم السلام ورحمة الله وبركاته. هلا مشعل، لسه بدري مشعل.
والله نايم يا استاذ معلش.
It's okay, it's okay. No problem مشعل. مهند. It's okay. So as this Saleh. Are you here, Saleh?
Yes.
Yes, okay.
Yeah,
Saleh, this is carbon. Carbon C6,
Yes.
C614. Carbon 14 changes to nitrogen. 7 and 14.
And
So
14.
what about beta particle? This was 6, became 7, became
Yes.
7. So atomic number here equal what?
8. 8.
No. Why 8? Listen, please, Saleh. This is carbon was 6, became 7. 6
Yes.
became 7. So the charge here equal what? What is the right number that can be written here? Okay, plus 7 to be 6. Understand me?
No.
What is the number that must be written here? Okay, plus 7 to produce 6.
1.
Not 1. If you put 1 plus 7 will be 8, not 6. So it will be what? It will be -1.
-1.
Yes, it will be -1. So 7 -1 equal what? Equal 6.
Equal
what?
6.
And this 14 became
Yes.
exactly 14. So here equal what?
14.
No.
0.
0, because 0 plus 14 equal 14. Understand me?
Yes.
So we said that beta radiation is a radiation that has negative charge, and emits beta particles. Each beta particle is an electron. So beta particle as electron, as its charge is -1. During beta decay, a neutron is converted to a proton, and an electron, the electron is emitted, and the proton stay in the nucleus. Okay, proton stay in the nucleus. Why? While beta decay convert into a proton. It's okay. Electron is emitted. So beta particles are similar to electrons. Why? Because they have -1 charge. Negative what? 1 charge. Understand me, guys? Any problem till now? Any problem till now? It's okay. So This is the radiation that we said before. This is called what? This is called radiation that we said before. So after that, after beta particles, okay, this is called what? This is about gamma rays. Okay, to differ between alpha, beta, and gamma in radiation deflection. If you get lead block box made of lead, because lead is very strong, that don't allow to any particles to emit from it. This is a radioactive source. Radioactive source as a radioactive element. Radioactive source as a radioactive element. And this is a hole. This hole that can rays penetrate from it. This is positive plate and negative plate. Why? To understand positive with positive, okay, will repel, but positive or negative will attract. And this is negative. Negative with negative will repel, but negative with positive will attract. But if
Mr.
these
Mr.
rays have no charge, it will be moved in a straight line without any deflection. Yes. Who can
Mr.
answer?
The
Yes.
quiz that we take it before 1 week will come in the report.
Inshallah.
But they say
I said that I said that if you have choice to repeat it or not, and I said that I will make another one in next Thursday, inshallah, to improve
but
your
Mr.
mark.
Mr.
Yes.
they say درجات الترم الأول بنفس بيخلون
Yes,
بنفس
yes,
الدرجات.
yes, yes. I see. You can explain.
طيب وش الفائدة يا أستاذ؟
You can explain this phenomena and this message with Mr. Thamir Hussam. It's okay. Please, Hussam, can you let me to complete our session and not ask me in a question out of our session?
Okay.
Okay, Hussam, thanks. So in this, I said before that we must know about the charge of this radiation. So we have positive radiation, negative radiation, and neutral radiation. So this is positive. Alpha particles make a deflection. This is called beta particles. While beta, because beta negative, and negative make what? Make attraction to positive. Positive and negative attract each other. So beta will move upward. Why move upward? To make attraction with positive plate. While alpha particles positive. So alpha particles will deflection downward. Why? To make attraction with negative, because it's a negative plate and alpha particles have positive charge. So positive or negative will deflect, will attract each other. So alpha particles will move downward. This difference between beta particles and alpha particles that we said. So we put positive plate and negative plate. When positive make attraction with particles, so the charge of these particles must be negative. And when we put a negative, and we will observe that there is rays that attracted to negative, so the charge of these particles must be positive to be attracted with negative pole. But these rays that pass in a straight line, without any deflection to upward or downward, so it have no charge, that's called the gamma rays. So by this picture, okay, we explained this. There are three types of radiation. That can penetrate from any radioactive element, which are beta particles, have negative charge, positive particles, which have positive charge, and gamma rays that have no charge and move in a straight line. Understand me? Okay, so this video that you are going to explain it on Magro Hill site. Listen, please.
Radioactive elements can spontaneously emit three different types of radiation: alpha particles, beta particles, and gamma rays. Carbon-14 spontaneously emits beta particles from its nuclei. Since beta particles are attracted to the positive plate of an applied electric field, they must be negatively charged. In fact, beta particles are electrons that are formed and then emitted from the nuclei of certain radioactive isotopes. In the decay process, a neutron is converted to a proton and a beta particle. A carbon-14 nucleus contains 6 protons and 8 neutrons. During beta decay, one of the neutrons is converted to a proton and an electron. This electron, called a beta particle, is then ejected from the nucleus, producing nitrogen-14. A nitrogen-14 nucleus is stable. Thus, no further radioactive decay occurs. Cobalt-60 is used for radiation therapy in treating certain cancers. It spontaneously emits gamma rays from its nuclei. Since gamma rays are undeflected by an applied electrical field, they have no electrical charge. Gamma rays are very high-energy electromagnetic radiation. They have no detectable charge or mass. A cobalt-60 nucleus contains 27 protons and 33 neutrons. When a gamma ray is emitted, the number of protons and neutrons in the nucleus is unchanged. The half-life for this process is 5.26 years. This means that half of a given sample will undergo this process every 5.26 years. Radon-222 is being formed continuously in our environment by decay of uranium-238. Radon, being a noble gas, is chemically unreactive. Therefore, it is not trapped by chemical processes in the soil or water, and is free to seep up from the ground and into homes. Radon spontaneously emits alpha particles from its nuclei. Since alpha particles are attracted to the negative plate of an applied electrical field, they must be positively charged. A radon-222 nucleus contains 86 protons and 136 neutrons. During alpha particle emission, a particle composed of 2 protons and 2 neutrons is emitted. An alpha particle is equivalent to a helium-4 nucleus. When an alpha particle is emitted from a radon-222 nucleus, a polonium isotope, polonium-218, is produced. Since an alpha particle contains 2 protons, the atomic number decreases by 2, from 86 to 84. An alpha particle has a mass number